Hello everyone. Today we will be learning about binomial distribution. Binomial distribution is something that's used to find the probability of an event that has two outcomes. Okay, so it has to have two outcomes, and we usually determine these outcomes as success and failure. And the classic example of a binomial distribution is a coin flip. You can either get a head or a tail. And I guess which one you determine as success and which one you determine as failure depends on the situation, but it has two outcomes. One, if you determine head to be success, it has a success part and a failure part. So that's where the word binomial actually comes from. Bino means, or bi, I guess, means two. And you have two outcomes. I should say outcomes here. Two outcomes in a binomial situation. Okay, and another thing about binomial distribution is that the events must be independent. Events must be independent. Oops, not independent. Independent. And I guess this, we can again refer to the coin flip. The first flip is not going to affect what you get on the second flip, right? So the coin flip passes as a binomial distribution, whereas other events as picking marbles, picking two kinds of marbles without replacement will not be a binomial distribution, because which marble you pick first, if you don't replace it, it's going to affect which marble you pick the second time. And again, a die roll is not going to be a binomial distribution because it doesn't have two outcomes. It has 6 different outcomes. Okay, so for it to pass as a binomial distribution, it needs to have two outcomes, success and failure, and it needs to be, the events need to be independent. And the probability of success or failure needs to be constant. And the probability, because there are only two outcomes, you can either succeed or fail in a binomial distribution. If you know the probability of one, let's say that the probability of success is 0.6, then you can know the probability of failure by just doing 1 minus that, 0.4. Or another way of saying that is the probability of success plus the probability of failure has to equal 1. So the probability of success is 0.5, failure has to be 0.5. And this, I guess, would be the case of flipping a fair coin. And you can actually extend this problem to not just coin flips, but to other kinds of problems. And let me show an example of how to do that. So let's say that we've invited Stephen Curry to throw some free throws for us. And let's say that he has a 70% chance of success of making a free throw. If he throws 5 times, what is the probability? What is the probability that he will make it? That he will make it 3 times. Okay, so first of all, let's see if this passes as a binomial distribution. First of all, are there only two outcomes? And yes, there are. You can either make a free throw, which is success, or you can miss, which is a failure. Okay, so there are two outcomes. are the throws independent? If we assume that Stephen Curry doesn't get tired, and I don't think he will for throwing 5 free throws, then the first throw is not really going to affect his second throw. The second throw is not going to affect his third throw. So the events are independent. And the probability of success or failure, we're setting the probability of success to 70% here. So that is constant. So this can be seen as a binomial distribution. And let's see if we can actually solve this problem here. So if you have, let's think of the different cases of how Stephen Curry will make the basket 3 times. So I'm just going to use S and F for success and failure. He can succeed the first time, succeed the second time, succeed the third time, and then miss the last 2 times. He can succeed the first 2 times, miss on the third one, make it on the fourth one, and miss on the fifth one. He can make it on the first one, miss on the second one, miss on the third one, and then make the last 2 times. And you'll see there are different ways to make the basket 3 times. And notice I'm just doing it for 3 times. I'm not doing it at least 3 times. So this is just making the basket 3 times. Well, if you assign a place for each of these, let's call this 1, 2, 3, 4, 5. It's the same for all of these. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you can think of this as choosing the places for the success. So in this case, in the first case, I've chosen 1, 2, and 3 for the spots for success. On the second case, I've chosen 1, 2, and 4 for the spots for success. 1, 2, and 4. On the third case, I've chosen 1, 4, and 5 as the spots of success. And this right here is actually just picking 3 numbers from a group of 5 numbers, or it's just picking 3 spots from a group of 5 possible spots. So this right here is just out of 5 spots, we're choosing 3 spots. Okay, or you can write that like this. 5 choose 3. And why are we using a combination here? Well, in the first case, if you switch these 2 successes, are those going to be 2 different outcomes? No, if you switch these 2 successes, it's still going to be the same thing. Right? So the order of the success and the order of the failure is not really important. It's just the different ways of how those 2, success and failure, are combined. That's important. Okay, so that's why we're using a combination here. And if you find all the different ways of picking 3 successes, that will be this number right here. And just a reminder, that is 5 factorial out of 3 factorial times 5 minus 3 factorial. And that actually equals 10. Okay, so there are 10 different ways. There are 10 different ways for Stephen Curry to make 3 baskets, given 5 tries. Okay, and so what's the probability? Well, let's calculate the probability of each of these. Right? If you calculate the probability of each of these, and since these are independent, if you just multiply them by 10, then we'll get the overall probability, right? So let's find the probability of one of these. The probability of success, 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 and failure. Okay, so the probability of success, succeeding, is 0.7. Another success is 0.7. Another success is 0.7. And then failure is 0.3. 0.3. Okay, so let's see what that gives us on the calculator. That actually equals 0.03087. And all these other cases, this case, and then we're going to have more cases, I just didn't write them here. the probability is still going to be the same because you're multiplying the same numbers, but just in a different order, right? So you're going to have 10 of these, 10 of 0.03087. And remember, for OR probability, it's either this or this or this, which means you're adding them all up. And since there are 10 of those, as we've calculated here, to get the overall probability, you just need to multiply the 10 times this. Okay, so the probability that Stephen Curry makes exactly three baskets out of 5 will be about 31%, or there's about a 31% chance that he will make exactly 3 baskets. So now let's see if we can generalize this case so that we can also find, or we can also easily calculate the cases when he's throwing 100 times or like 1,000 times. Okay, so let's, instead of making this as 5, let's call this n, and let's call the number of successes, which is 3 in this case, let's call that k. And let's see if we can generalize this. Well, for the first part here, so basically what we've done here is we've multiplied the combination times the probability. And to get the combination, you have chosen the success cases, the possible success cases out of the total trials. Okay, so if we're replacing n for 5 and k for 3, then we can just write the first part as n choose k. We're choosing k successes out of n trials. And for the probability part, we had the success probability. We've multiplied the success probability by the number of times he will succeed. Okay, so in this case, we were asking how many times, or what is the probability if he succeeds 3 times. That's why we've multiplied the 0.7 3 times. So this would be the probability of success times, or to the power of k, right? This is the number of successes that we're looking at, and we're multiplying that probability to the kth power. And the second part here, I guess I need a little bit more space. Whoa. Oh, that was, all right. This would be the probability of failure. It's the probability of failure, and that's going to be 1, or I should say, n minus k, right? Out of total of n trials, I'm succeeding k times, so the number of times I'm going to fail is going to be this many times. So this right here is the general formula for binomial situations. And in the case of Stephen Curry, we just used 5 for n. Let me actually use a different color here. We've used 5 for n, 3 for k. Probability of success was 0.7, and k was 3. Probability of failure was 0.3, and the number of failures would be 2. And if we calculate that's how we got this number right here. Okay, so now let's extend this problem, and let's change the question to not how many times will he get exactly 3 baskets, but what's the probability that he will get at least 3 baskets? At least 3 baskets. And this was the case with 3 baskets. And to find the probability of at least 3 baskets, you can just calculate the same case where he makes 4 baskets and where he makes 5 baskets, and just add those probabilities up. And you'll get how much, the probability of him making at least 3 baskets. Or you can find the probability of 0, 1, and 2 baskets, and subtract from 1 the probability that you would get by adding these 3 cases.